Hello, welcome back to this thing that I kind of been neglecting for a little bit. I do apologize for that. I've been a mixture of tired, busy, and really extremely lazy to the point where I'm actually going to clean my glasses while I talk about this. On the plus side, I have a green screen. It's not great, but it cost me like 30 bucks delivered, so who cares? And my hair looks terrible, but I mean, that's normal, right? So let's talk about stuff. Today we're going to talk about classes. What are classes? And classes and structs and other data types. What it means, what they do, and a lot of stuff that goes with it. I got my list of stuff that I'm going to talk about here. I was like, well, it doesn't really make sense without some kind of preamble, so I'm just going to leave it and we'll sort of go through it as we go along. Yeah. So let's talk about data types. So if you've been watching along, you've been introduced to data types like int, string, char, bool, all those kind of things. Now, except with the exception of string, they're all built into the language. They're all very basic, and they're called basic data types. String is the exception there, and string is actually a class. So you guys have already used classes by this point. And the way it works is a class is a collection of data and functionality. And it does some really useful stuff. And this is where, if you've ever Googled like C++, you might have seen this thing called OOP, or Object-Oriented Programming. Oh, excuse me. And this is where it actually comes into play. And we'll go through it as we go along, what an object is and how that all works. And I'm just going to bring that up actually, so I don't get the definition wrong. So you'll excuse me. Yes. So the thing about me is, like, I forget the basic terms. Like, I was once in a job interview and they're like, what is inheritance? And I'm just like, blank. And I'm like, when they were like, it's this thing, I'm like, oh fuck yeah, of course it is, and this is how you do it, and this is how it works, and this is why you do it. I was able to give them every explanation. I just forgot what the term was. And I had never looked so stupid in an interview before. Yeah, cool. So object-oriented programming is where you program from a data perspective rather than a functionality perspective. So your data defines how you program rather than what you need to do defining how you program. I know that seems a little bit backwards and I'm probably explaining it a bit wrong. All right, sorry about that quick change, and I forgot what I was talking about. So yeah, we're going to learn about classes and objects and how it all fits together and why C++ is the greatest thing ever, in my opinion. But I mean, everything else has it as well, so whatever. So today, classes. What is a class? Well, much like we were talking about with the string example, a string is just a collection of data and functionality. A string is a bunch of characters. It's an array of characters, basically. But it also has other functionality built in, like string concatenation, so you can add strings together. Excuse me. String like left, string right, so you can cut a string up, and like substrings, finding stuff, all that kind of thing. All that functionality built into strings is what makes it a string rather than just like an array of characters. That's why you don't use a character array. You just use a string if you need all that functionality, which generally speaking you do. And comparisons is an important one. So today we're going to make our own class. Now, I haven't really thought ahead about what we're actually going to make, so it will probably be something incredibly simple, but it should give you the basic concepts about how classes work. So let's talk about, firstly, why you use classes. So let's say we have a page of a book, or just a book, okay, a book. So a book is going to contain a string, standard string, sorry, for the words in book, because it's a really great name. And then we're going to have a string for the author and an int for number of pages and an int for published year. Cool. Now we can go and fill all that stuff in. So we go words, book is hello, my name is Frank Walker. Author is Jason. Number of pages is 1. And published year is literally never, so -1. We're not going to publish this shit. So we've made a book. It's an extremely simplistic representation of a book, but I mean, you can fill in the blanks for yourself. So now let's say, oh, well, that's cool, but now I want to build a library of books. Well, fuck, now I got to do that again. All right, cool. So we'll copy and paste all of this. And it's like, okay, now it's words in book 2, and author 2, and number of pages 2, and published year 2. And I mean, I'm not going to change the data. You can sort of get an understanding of what's going on here. Now we have 2 books, but that was a pain in the ass. And now I'm going to go, oh, fuck, I forgot to give you the, I don't know, the age of the author at the time of doing it or something. So now, fuck, I got to go into here and go author's age. And I got to go here and go author's age 2. And I got to fill that in. What was I? I was 21 when I wrote this book. That's true. Don't question it. Oh, well, that's a fucking pain in the ass. Could you imagine if you had 100 books and you had to go, oh, no, I got to do it for 100 times. That's crap. Okay. And what about, oh, okay, now I want to format this book so it looks good. And I can print it out to the screen. So I'm going to go standard, C out. And it's going to be, I forgot the name of the book. Okay. There's a perfect example of me missing something and I got to go do it again. Like legitimate, like, failure. Jason's awesome book of awesome stuff. Okay, cool. So I'm going to go title by author, published. I'm going to stop at published, but you get the idea. And published here. Okay, now I got to do it again. Change this to that one, and that one, and that one. And then I'm going to go, fuck, you know what? I actually want it to say published in. Now I got to change it twice. And then I got 100 books, so I got to change it 100 times. And let's do a stop. And let's just look at it, make sure it's all running. Yeah, it's published in -1. Anyway, that's what you'd expect to see on the screen. Forgot the end line, but you know what? Sue me, I'll do it now. And look, now I gotta change it twice, once again, which is shite. So now we have these 2 pieces of data, we have some functionality down here, which is printing it out to the screen, and it's fucking garbage. This is shit to maintain, it's terrible to use. I gotta copy and paste code, copy and paste data. How can we avoid this? Well, you're in the right place. We are going to use a class. Now, once again, I'll say it again, a class is a collection of data and functionality. You don't have to have data, you don't have to have functionality. If you just wanted something to hold these 6 pieces of data, great, we can use classes. If you wanted something just to hold a function, great, we can use a class, that's fine. There are definitely situations where, I'm gonna close Steam. No, don't install Steam VR, Jesus Christ. There are definitely times when you will want just function, there are times you will want just data. That happens extremely often, it's extremely common. But we're in a really good position where we're gonna have both. So let's talk about how we actually create a class, some syntax behind it, some funky stuff that can go on, and how we use it. So the first thing we want to do is make a new file. Now, there's this C++ class here, and there's a header and a CPP file. I will explain these two in a later video. We're going to do it just the simple way. See, this is the thing, like, because doing it the simple way, I always forget how to do it properly. Like, do it the simple way, which is the wrong way. So I guess we should just do it the right way. No, okay, we'll do it the simple way. So you want to create a header, and I'll explain why as we go about what the difference is and all that kind of stuff. Train of thought's gone. Okay, so we're going to call it book with 3 O's because I am a smart lad. So now we've got a new file. Okay, what do we do from here? Well, first thing is we're going to do our includes because we do need string. So we're going to include string. Now this is where we get to the syntax, which is my favorite bit. The syntax for creating a class is very simple. It is class and the name. And then some curly braces and a semicolon. Now I've called it book with 3 O's to match the name. Just roll with it. We've created a class. Much like string, we can use this class already to create a piece of data that is a book. So let's just very quickly do that and I'll show you what's happening. So what do you think the first thing we need to do is? Just think about how strings work and what we need to do first before we can use a string. What do you think we need to do? If you said we need to include the book file, then you're a fucking genius. Why are you here? If you didn't, let me explain. We've got the functionality we just created in a different file. This main file does not know about books. So we have to tell it by including it. So we go include, and now this is where it differs a little bit from the way we've been doing it previously. The angled brackets is a, go look in all of the include directories, which includes all your Windows stuff, all your C++ stuff, and all that kind of stuff. What we want to use is we want to use the quotation marks. So that's telling me to look in the local directory, and you see it's there, book.h. It's a very subtle difference. You can do like this, but the implication is different. What's this complaining about? Oh, okay, it's just not going to work because I haven't set it up. You can put your local file as a include directory as one of the settings, but to be honest, you just want to sort of, it's a good way to differentiate. This is something I wrote, it's got quotation marks, something someone else wrote. Let's create a book. Book, my book. Just like creating a string, we have created a book. Now, at the moment, we can't do jack shit with it. It has no data associated with it and has no functionality associated with it. So let's fix that. So before we do that, let's talk about something. It's going to be a little bit off the beaten track, but we need to talk about it first before we can go into it. And it's called an access modifier. Now, by default, a class has a private access modifier. So let me just explain that. The access modifiers are the two main ones that we're going to talk about today, a public and private. And what it says is things that are public, everyone can access. Things that are private, only things that are internal to this class that can access. So by default, everything we put inside this class can only be used by the things inside the class. Now you may be thinking, well, what's the fucking point? And for the most part, you're right. But when we go into a little bit further on, you will see why. So first thing we need to do is change the access modifier. So we want it to be public. So to change an access modifier, you just go public or private, depending on what you want to be, your colon, and that's it. Everything from underneath that to the next access modifier or the end of the class is that access modifier. So everything I put here will be public. And that means that main.cpp can access it, anything that you write can access it, anything else that I write can access it. So it's the most simplest way of doing things, but big caveat, asterisk, it's not always correct. In fact, it's usually the opposite. Usually you want some stuff or most stuff to be private, but we'll go into that as we go. So let's cheat. Let's copy all our data from main and just shove it in there. Cool. Now, how do we set things? So this here, this my book, that is called an object or an instance. It is one created type of a book. It is one book sitting on your shelf. You know that your Ernest Hemingway book is a book. You know that your Philip K. Dick? I don't read. All right, it's not a brag, I just don't. You know, is a different book. You know that your collection of poems is a different book. You know your Playboy magazine is a different book. They're all books. They all contain the same stuff. They're just different iterations of a book. It's a different book. That's what this is. This is a book. One book. You can have my second book. I really wish I typed that properly the first time. And now we have 2 books. And if you want 3 books, well, now we have 3 books. And because we've talked about arrays, if you want to go one step further and go book, books. Is that the right one? That one. No, once again, it's one of those things that I never use. I never use arrays. Okay, there we go. Which is actually funny because that was another thing that same interview I screwed up. It's like, write this using only arrays and don't use lists. I'm like, who does that? Anyway, it's not like I can't do it. I don't do it very often. I have to like look it up again. So there we go. We'll just get rid of those 2. We have an array of books and we have a book. It's all the same. It's all the same as using ints, strings, chars. It doesn't matter. It's all the same shit. So how do we assign data to a book? Well, with a string, you just go, you know, words in book 2 is equal to my new words. Well, the thing is though, the left-hand side is a string and the right-hand side here is a string, so that's why that works. We just can't go, you know, my book is equal to my new words. That doesn't work because the left-hand side is a book and the right-hand side is a string, and it'll just say that. There's no operator equals that matches book equals a string. That's what this says. Well, what it actually says is no operator equals matches the operand type are book equals const char 13. Breaking that down, it says you got the book on the left, you have a string on the right. I don't know what to do with it. So this is what we do. Now, in C++ and in actually most languages, it works the same. You have your full stop, your period, as an operator. I think I've spoken briefly on operators, but they're just sort of like shortcuts for functions, basically. This is a special operator, though, because it allows you to... I love when I talk about coding, because my watch is like, hey, keep up that workout. I've been working out for 10 minutes and I've burnt 44 calories. This operator means whatever's on the left, we're going to use the dot to drill down one level. So if we go my book dot, and you'll see all this stuff pop up, we can now access everything that is public in our book class. So if I now want to set the author to myself, we have gone, this book's author is now Jason A. That is one book that we have created that has an author of Jason. Let's go and actually create our second book again. Because now we can go, my second book dot author is equal to Yo Mama. Because I'm a very intelligent person, I make the most intelligent jokes. And now, if I was to go C out, and once again, just like using a string or any other piece of data, and I'll explain that in a second. Do this shit. Let's not output that. Now you're going to see on the screen is the 2 authors, Jason A and Yo Mama. Cool. So how does it work? Well, this here, when you use this, you are grabbing words in book 2, and then you're going assign this thing over, the other way around, assign this thing, it's hard backwards, this thing over here to this thing over here. What we're doing here is we're grabbing my book, then we're going, okay, let's grab the author from the book. So we grab that now, that is in our hand. That is the thing we're currently holding. And we're going to assign Jason A to that. When you drill down, you start grabbing that thing. And that's the kind of thing you need to map out in your mind. So you have book, then we go in here, we grab the author out. We have now the author in our hand. So anything we do on after that is now relevant to the book's author. So this here is we've grabbed my book's author and now we're going to output that to the screen instead. And the same thing here with the second book's author. So now what we can do is we can go and fill out all this stuff pretty easily just by copying and pasting that. Get rid of the author. All right, and we'll leave that there. And now we can take this. Oh, actually this one will probably be easier. We can take this, comment those two out. And I guess that one too. And grab this, the title, the author, and the published year. And what we're going to see is exactly what we saw before, except the name's different. Jason's Awesome Book of Awesome by Jason A, published in -1. Sweet. That's awesome. We have now successfully used a class. And hopefully the usefulness of this has come across so far, because now if I go, oh, okay, I want to know what the publishing house was for this book. I can just go here and go, okay, now you have the option for every book you've created to have a publishing house. So now I can go over here and go, my book.publishing house is going to be Penguin, because that is the only publishing house that I know. And now my second book will have that, my array of 10 books will have that, the book that you've created in your code will have that, all have access to it. That's awesome. So if I've just got a collection of data, where does that functionality thing come into it? And hopefully you've kept up, and hopefully I haven't gone sort of over the finer details a bit too much. I don't want to dive too far into how it all works, simply because it's kind of irrelevant at this point. It's more relevant for you to know how to use them rather than how they work at a very fine level. Yeah, okay, so we have our book here, but now we're still outputting this manually. So now if we want to output our second book, we've got to copy paste this and do this and this and this. What we can do is we can use a function. And much like, which I didn't explain 10 minutes ago, these here are variables, but they're part of a class, so they're called member variables. They're a member of a class. Remember that? I remember. So now we can add functions. We can add functionality to this. They're called member functions. And they got some really cool properties to them. So we're going to create a function that outputs that really nice formatted string that we displayed on the screen, you know, published in this, by this, etc., etc. So let's create a simple function called output that will take no inputs. A function called output that outputs a string that takes no inputs. That's only a little bit confusing, I know. Now, why haven't we taken any inputs? Well, because this function here, because of the way it works, has access to all of this. All of that information there, it has access to. We can go here and go words in book. Just return words in book for now. And this function will output the words in book for the object that you call the function from. Now let me go and explain that. So out here, we're going to get rid of this. And what we're going to do is to cout, and we want to take my book and use the output function. Oops. Like this. So now what we've done is we've got our my book object, which has all this data filled out. And we are going to call the output function on that. So that the data that that function will run on will be the data here, but it will be the data filled out in my book. This is the data we'll be running it on. So when we output this, we expect it to say, hello, my name is Frank Walker. Perfect. Great. Now, this is where the power of having something like this happens. So I'm not going to touch main.cpp at all, okay? So that's going to go away. We're over here. Now, every book that you have created, every book that I've created, every book that that guy over there has created, that girl over there, that thing over there, whatever, My dog has created a book and has not eaten it yet. We're going to change the way it's outputting to the screen because I've had complaints like, well, this is shit, it's just outputting the words. You're right. So let's output the, let's start with this. Change all these to pluses because this is slightly different. Change my book to just title. What are you complaining? Oh, it's a, the function is standard to string. Yes. So we've called a function from a namespace here. And what this does is just convert a string into a string so we can use it in this kind of string building thing. There are other ways you can do this magically, like cout here does it magically by using these things. It knows how to handle ints. I think it does the exact same thing under the covers. It's just one less step. And we want to add in a new line character as well. Between our words, what are you complaining about? It's not an unknown type, it's a char, you jerk. All right. So what we've done here, this /n, that is the same thing as endl. Actually, I think it's /r/n. I don't remember what it is, to be honest. I don't do this kind of thing very often. I'm pretty sure it's that, in Windows at least. So now, I haven't touched main. Not at all. Now look at it. Fantastic. Okay. Well, now they want to know published in, and they want to say by, oops. And published by the publishing house. And let's put this on the next line, it's a little bit neater. Thank you. Published by Penguin. Sweet, we haven't touched main. We've edited our class functionality. We've changed the way the function works to be better, and you, as the end consumer, have not had to touch anything. This is an extremely, extremely simplistic example on how this works. You could, if you're sort of having like all galaxy brain thoughts right now about how you could do stuff like this and how it'd be cool, you're probably right. If I wanted to give an example, I have items in my game that I'm building at the moment. I make one item class and all of a sudden I'm like, oh shit, I want to add, flavor text. I add a flavor text in one place and then every item has now got flavor text. And if you don't know what flavor text is, that's like when you mouse over an item and it says, this sword was forged in the fires of Mount Doom and killed Frodo. A man can dream. So that's one really great thing about it. Another great thing is all of a sudden, I've got some math class, like a vector, and a vector is just 3 points in space, your x, y, and z, or your x and y, your x, y, z, and you get the idea. It's like, okay, well, it used to just be 3 numbers, but now I can do calculations on it. I can work out what the length of the vector is. I can work out what the, I can't remember the term normalization of the vector is. And I will add that to my vector class, and then you have that ready to go because you are already using my vectors. So when I go and add functionality in my class, it's there for you to use. And that's like brilliant. You can imagine that if you were using someone's game engine and they only did like really basic 3D models, and all of a sudden they upgraded their 3D models to have animation. You've been using the 3D models, now you have animation. Then they update it to have cutscenes, and then all of a sudden, you can use that to have cutscenes. You can just use the additional functionality without having to rewrite everything. That is where the power of classes comes from, and why they are very popular and very common now in languages, whereas C++ was one of the first, I think, one of the first anyway, languages to actually bring that to the table. And now C#, Java, PHP, I think have classes. I don't know, I haven't used PHP very much. Excuse me, all have that functionality, and it is extremely common. There aren't a lot of languages that come out these days that don't have OOP, object-oriented programming or classes. So we've talked about the basic functionality of classes, but I want to dive a little bit more into some of the things we can do. and why this stuff becomes just so fucking powerful. So this stuff here, if I create a book, I can create a book with a publishing year of -1. I can create a book with an author's age of 7,000. These things do not make sense. Maybe the publishing year as -1 is like a basic thing, makes sense, or 1 BC, I guess, so maybe that does make sense. But having an age of -1 makes 0 sense. Having an age of 700 doesn't make much sense either, unless you're talking about biblical stuff, which we won't, because fuck that. So what we can do is, we can hide away our data, and then give the end user very specific means to access our data, so that we can do things like validation, we can do extra functionality, and we can do all that kind of fun stuff. So let's sort of talk about that and how it's going to work. If you remember about 10 minutes ago, I was talking about, the word has escaped me. See, this is what happens when you're a programmer. You know how to do things, but you don't know how to explain shit. Access modifiers. You have public, which is everyone can access, and private, which is only that class can access. What we can do is we can hide our data, our raw data, and provide functions to set and get that data, to read and to write that data, as a way of validating the input and a way of hiding away our data so that the end user can't fuck with it. So the data is always in a format you expect, it will always be correct. So let's do the first step, okay? Let's hide away our data. I hit the wrong button, I hit Z instead of Control X. So let's cut all that stuff away. Let's change our access modifier back to private. Now you're probably thinking, but you just said that private is first, why would you go public and then back to private? Personal preference, I like the public stuff at the top so that when you open my class, you can see everything that you can access publicly, and then the private stuff you don't really give a shit about. That's the way it makes sense to me. If you were to go the other way, that's fine, just be consistent. And like, sweet. Now, if we try to run this, or if we try to build it, it's going to say, what the fuck, dude? Oh, I'm building everything, aren't I? Oh, you jerk. Ignore that one. This one here, cannot access private member declared in book, cannot access private member declared in book, cannot, etc., etc. And we go over here and you'll see it. Cannot access private member. Member book author is inaccessible, which means that you can't access it. The access modifier is incorrect. Just have a bit of water here. So we need to provide them with means to access that data. So let's leave this output function on the bottom. And this is where a couple of terms are going to come up, and I'll explain them as we go. Hiding your data away is known as encapsulation. You are giving people very specific access to what they can and cannot do in your data. It is hidden away, it is encapsulated. When you write functions to read and to set read and write the data, they're called getters, which is retrieving, and setters, which is writing. Generally, there's no real format for, well, there can be, but I'm going to give you my format for getters and setters and why I do it, and hopefully it makes a lot of sense. So a getter will generally be, the return type needs to be, once again, generally you might be fucking with some other stuff, but generally will be the data type that you're getting. So we're going to get words in book, so we're going to return a string, because that's what words in book is. The name of the function is going to be get, then the name of the variable, words in book. Now, once again, this is my personal preference. You might have something else. You might just call it words in book. That is valid. I don't like that, but you can do it. You can have, and I'll explain, have I already explained overloading? I don't remember. I'm going to put it down though. Function overload. There are things you can do where you can have, because everything needs to be unique, but you can have functions named the same that do different things, but I don't suggest it. I personally don't like it. But once again, that's completely up to you. As long as you're internally consistent, you're good to go. Now, we don't need to know any variables to input. We don't have any parameters. So that's all it's going to be. And all this will do is return words in book. That is the general syntax for a getter. Return type is the variable. The name of the function is just get the variable, and you just return the variable. And now setters is the opposite. We want to set words in book. So we don't want to return anything, we're just setting. So set words in book, and we want to take the data we want to insert into that variable. So it'll be a string, new words in book, or whatever you want to call it. Call it X for all I fucking care. It doesn't really matter. The end user doesn't see it, and when you see a setter, you assume. So words in book, oops, is equal to new words in book. Be good if I didn't. Just kill me. Just fucking fix it. Nope. All right. There we go. We have created a getter and a setter for words in book. Now you will notice down here we have not changed words in book, and it's not underlined. It's not a problem because this output function is part of this class, so we can access the private methods. It's good to go. And the method itself is public. So you can access my output function, but you cannot access the data underneath it by yourself. But I've given you access to it. You might not always want to give access to data in here. Maybe you have something like amount I paid the guy, the writer. And maybe that's calculated with a formula, and you don't want the general public to see it, but maybe there's something you can do. You know, then that data is going to be private. It's going to stay like that. It's not really the way it works, but just a sort of thought exercise. So now what I can do is I can go here and I can replace this with my book, because we want to call the function on my book. And we can set the words in book to hello, my name is Frank Walker. That's great. We have done one. So let's extremely quickly go through the other 6. Good God. I'm going to actually just change this to data because I am extremely lazy. Can I have 4 strings? Okay. So author, and I've done this the wrong way, but that's fine. Title, and publishing house. Set that. Yes, I know my capitals are wrong, just sue me. You get the idea. Now, generally speaking too, I've done it wrong here. I generally set my functions to have a capital letter, to upper camel case rather than lower camel case that I use for variables, but once again, as long as you're internally consistent, which I haven't been, then you're good. So let's go mybook.set author to me and set title. Now, unfortunately, I can't use the equals, so that's fine. So I'll set publishing house to Penguin. So we have set the 4 strings. Now we just got to do the same thing for ints, but I will show you why that you use encapsulation here. So let's talk about the number of pages. So we want to do our getter. That's easy enough. Get number of pages, return number of pages. Now let's do our setter. Set number of pages to data. Okay. Now we can go, all right, we're going to accept between 1. My exercise is over. That was a great workout. Can you see? I've done a great workout. 30 minutes, 132 calories. See, this is good for you. Coding is good exercise. So let's talk about how we do this and why we do encapsulation. This is where it all comes to pass. We can do validation when the data comes in. If you come up to me and tell me you're born in 1738, I'm going to go, that's incorrect, mate. And then you'd be like, oh, sorry, I mean 1988. It's like, that makes more sense. That's more believable. I can do the same kind of thing here. I can go, if the data, which is the new number of pages, is more than 1, and the data is less than 1,000, the 999, then we are going to allow our number of pages to equal the data. Otherwise, we're just not going to change it because it's bullshit. That's where encapsulation really shines. I can go, all right, you've given me a piece of data. I can make sure that that's correct. Why would I do that? Well, simple reasons like this. This is a very simple way. You can go, well, you know, the programmer is going to know he's going to do it properly. No, programmers are idiots. And on top of that, you could then go later and go, well, 999 is kind of a stupid number. You could have books that are 5,000 words. You have 10,000 words. We just want to change it so it's at least one page, which that is not at least, that's that. Okay, cool. Now our validation has changed. Or we can go, we're going to allow this to be 0 if they haven't started writing the book yet. So we can just enter something into our book registry. Well, now we can go, as long as the data is more than or equal to 0. You can continuously change these conditions so that things will work correctly in the future. And this kind of validation can be used in things like validating someone's birthday, say. If someone puts in a birthday that's 1850 at the moment, you're going to go, no one's that old. In 50 years, you can change that to 1900 because no one's going to be that old. And you can have these moving goalposts. So let's just quickly finish off our other 3. Oh, we'll get rid of amount paid the writer. So we go published year. Now, once again, we're going to say our data needs to be between, say, minus 5,000 and 2019. So we can't have a book published in 2020. That doesn't make any sense. So we set the published year and get the published year. Wait, that's the wrong one. Published year. That was our other one, author's age. So the author's age, again, is a very simple one for validation. We can go as long as it's more than, let's say 10. I mean, let's leave it at 1. And less than 150. Because no one's ever lived that high. That much, that long, whatever. And then we can go back to our book and go, I'm going to set the number of pages to 1. Please fix. Set the published year to -1, which isn't going to work. It's going to throw up, not throw up an error actually. We haven't got any errors in this, but it's going to just not do it. And the author's age is going to be 21. Cool. And now let's update this function here and go, okay, the author was to string, what was it, age, author's age. What have I missed? So there's one author, I haven't got the title. 1, 2, 3, 4, 5. That's it. Okay. That's all. There's something missing. 1, 2, 3, 4, 5, 6, 7. What am I missing? Number of pages. There are this many pages plus. Cool. Now let's just put that on the next line. The plus can be up here if you want it. It doesn't really matter. It'll work. And now there we go. So it's still saying it was published in -1 because that is proper data. I forgot. So what happens if we put in -10,000? It just gives us garbled crap because we haven't actually filled it in. So wait, if I can't put in -8 billion, 85 billion, what is that? 858 million. Why can't it be 858 million? Can we do something that when it's created, where you set the data to, a neutral value, a blank value? Why, yes, we can. And this is one of my favorite things. We're going to talk about constructors and by extension destructors, but we're not going to sort of go into that one too much, but we're going to talk about constructors. So let's talk about this. we have created a myBook object of type book. Book with 3 O's. In the background, what it does is it goes through and allocates memory enough for all this and returns a memory address to you. This is where all your shit's stored, and you can do all this functionality on it. And this functionality here just goes, okay, my current instance is at this memory address, so grab all that stuff from there. By default, literally all it does is allocate space. The default constructor, the one you don't see when you do something like this, just allocates space. That's all it does. It doesn't do anything fancy, it just gives you the space you need. The data that is currently sitting in your RAM is that data that will be this. And that's not good. Because, as I said, I'm going to open this up now, it's going to be the same value because of magic, I guess. But it could be something else, and that's really hard to code for. You can't say, well, if they haven't given me a publisher year, then, just don't display the published year. You can't do that here. Whereas if you had some kind of default value, you could sort of code around that. So let's talk about that. How do we create a constructor? Well, a constructor is just a function. It is a special type of function, but it is just a function. The only thing about constructors that differ from normal functions is they don't have a return type. They're special. The return type is the class you're creating. It's inferred or implied. And the name needs to be the name of the class. So to do it, so we've got no return type, not void. Void is different. Void means you return nothing. This is literally no return type. So it's just book. There. We have created a constructor. Now when that book object is created, instead of doing the default thing where it just creates the data and just goes away, it's going to create the data and then jump into this function. And then we can do stuff like, okay, well, let's set our published year to 9999 because that's not valid data. They, as the end user, cannot set the published year to 9999. So I can then go, if that year is 9999, something has gone wrong. Let's just not display the published year. So let me show you what I mean by that. So in here, if I go and say, let's sort of move things around. So to return. So instead of just returning all that stuff by default, I'm just going to stick it in a variable and return it later. This allows me to build strings in pieces. So I'm going to go here and go, get rid of this plus. And I'm going to say to return plus equals. Plus equals means add to it. So when you do 1 plus equals, or int a is 5, then a plus a equals 5, it'll go 5 plus 5. That's a bad example. If you have a equals 6 and you go plus equals 10, it'll go 6 plus 10 is equal, and it'll throw that back into a. Man, I'm bad at explaining stuff. So let's just mess around with that. So now we have isolated published in here, and we can go if published year is equal to 9999, is not equal to 9999, then we will add this published year in. So now if we don't give them a published year, which by default with our current data, because our data is invalid, we're not going to give to them, that published year isn't going to show up. Oh, I really hate it when it fucking does that. The published year is now missing because that data does not exist. We have successfully created validation, default data, and handling of cases where the data is missing or invalid. We have done all that in the class, and the main stuff that uses it, the main.cpp object instance myBook, hasn't had to really update anything. It changed from being able to access the data publicly to using the encapsulated data with the getters and setters. But other than that, I've done everything in the back end. The end user of my code has not had to do anything. And that is why classes and reusable functions are fucking awesome when you do it right. You can do such powerful stuff. If you have a placeholder function, just say, called print this book to PDF. Then I go, okay, I'm going to put a button in there. It's not going to do anything yet, but it'll be there. And then a month later, I release an update that makes that function work. Your code just works. That's it. You've already done it. You were just waiting for me to do my end, and then it's just done. It's already finished. It's already done. That's actually quite a common thing to happen. You might write out a skeleton of a class, which a skeleton is just like the data and empty functions. And then I'll give it to someone else to go and be able to use those functions, set up the front end or set up a database or something for it. And then I can go off and do my stuff at my own pace, because if I don't give him that skeleton, then he can't do his work. But then they're waiting for me, and that's bad for my health, my mental health. So, all right, so let's just say this is messy. And it is. We have to call 7 functions on top of our constructor. That's a bit messy. Can we, go, my default, I don't want to have it just, do nothing. I want it to go through and actually be able to set the data at the beginning, just like a string. I can go, or an int, I can go int, my int is equal to 10. Can I do that with a class? Why, yes. Yes, you can. And let's talk about that. This is one type of constructor. This is your default constructor. And this is where that thing I was talking about before called operator overloading or function overloading comes into play. When you overload a function, or actually the definition of overloading a function is you have one name, but you have many types of functions that operate underneath, many different functions that operate underneath. Let's just say I tell you to write something down. If I tell you to write a number, now a number is an int. You know how to write an int, you just go 6, easy. I tell you to write a word, that's a string, it's a different piece of data, so you have to use a slightly different way of doing things, but you know how to write a word, it's just ASDF. Now they're two separate things, but you're doing the same thing, you're writing. You just do it 2 slightly different ways. You interpret the data differently. If I tell you to write 151, but I give you an int, you're going to go, okay, 151. But I could give you that as a string, as in O-N-E, H-U-N, etc. That's 2 different ways of doing things. 2 different ways of parsing that data. Same thing with build. If you know how to build things, if you're really good with your hands, and I go, I want you to build me something out of wood. I can just say build me, and I give you the name of the thing, say doghouse, and I give you the material, which is a class. Let's just pretend we have a class called material. This one happens to be wood. And you go, okay, I know how to do that. I'll get my hammer out, I'll get my saw, my nail gun, and some glue, some wood glue. And then I give you, instead of that, I want you to build me a doghouse out of metal. Same thing, same kind of stuff. You know how to build, you know how to do a doghouse, and you know how to use metal. So you go, okay, I'm going to get my hand saw out, my metal hand saw. I'm going to get my welder out. I'm going to get my hammer thing I can never remember the fucking name of. And I'm going to get some metal paint rather than wood paint. That's when internally you're doing function overloading. It's different. It's the same functionality, the same name, the same kind of operation, just using different pieces of data. So in this case, we want our default constructor to be, let's fill in the, what are the other 2? Number of pages and author's age. So number of pages is equal to 0, and author's age is going to be 0 as well. We're using 0 here because 0 is not valid data. We can then go into this, this output function and change it to actually check this data, but I'm being lazy, just pretend I did it. Now we're going to say, all right, we're going to give you, the end user, the option that when you construct this object, give me all my data. Give me the words, give me the publishing house, etc., etc., etc. The way you do this, it's the exact same way you do a function that takes all this data, all these parameters. So book with 3 O's, and we're going to take a string of words, a string of pub house, Yes, I'm being lazy. Shut up. What is it? Can I, like, peak definition? Yeah, let me do that. Beautiful. So IDEs are amazing, right? You can do shit like this. So I got words, I've got author. You generally want to put them in the same order that you expect to get them in. Stop making me look bad. Oh, I'm gonna bring it up here. Put it to a tab, please. Nope, it's not gonna let me. It doesn't matter. Peak. So publishing house, we've got title. Let's do it here because I'm lazy. And then we have int pages, int year, and int age. And then we can do one of two things. And depending on exactly how your data is situated will depend on how you're doing it. Now, we do have setters. We do have setters. But we're not validating everything. We're only validating 3 of our pieces of data. So we could do our, words in book. It's just equal to our words. That's fine. But our pages we're actually validating. So we can go set pages. Or set number of pages. So we are calling that set function from our constructor. And we are using our current object to do this. So if we go back into our main.cpp, our second book we're going to do with this. The way we call that constructor is you just open brackets, close brackets. So we've got open brackets, and you'll see IntelliSense actually helping you out here. You can see there's actually 3 constructors by default. I'm not going to go into those ones. And then we have this custom one we've created. So we can go words, author, title, house. And this is why giving everything good names helps, because it comes up under IntelliSense. It tells you what it's expecting. If you were to say A, B, C, D, E, F, G, they're going to be like, what the fuck are you talking about, mate? But I've called it words, author, title, house, pages, year, age. You can infer. Usually you'd call it something better, but once again, I am insanely lazy, so I haven't done that. So 1990 and 21. This has called that new constructor. Now this here is inferring the default constructor, but we can be explicit about it. Mate, are you equals this one? Yeah, that's the one. Sorry. This here is the same thing. This here is the same thing as well, if you want to be more explicit. This is generally the way I do it. I do like that explicit style of coding. There's no inference. You're reading it, you know exactly what's happening. But once again, it doesn't matter. If you can pass through your data and look at it without this, like this, that's fine. But when you get into other stuff in C++, this is the kind of method we use. And when we get into that, I think that's next lesson or the lesson after, into pointers, that will make more sense. Sorry, I've been talking for like an hour and my throat's dry. So now we can go here and we can put our second book output. And we can finish filling in our constructor. So once again, author isn't validated at the moment, but so is it? So this is actually a good example here. Look at what I've written here. Author equals author. What the actual fuck is happening here? I have called this thing author, but the data in the class is also called author. But if I build this, it's not going to chuck a wobbly. That is valid. Why is it valid? Well, because of scope. And I think I've talked about scope a little bit before. But if I haven't, the scope of the data is where it's sort of sitting. So you can have, you know, int a to 0, then go if true, because I can't think of something. You can go int a is equal to 0, and like continuously do that. I did that wrong. Like this. And these 5 A's are all different, and that's valid. I can build that again, and that will build properly. It's stupid. It is really fucking stupid and really confusing, but it's valid. And there are times you are going to want to do something like this, and the example is exactly what I've just done. Now, by default, the scope it uses is the closest to where you are. And generally speaking, you have no way to define what scope you want to use. The exception is where we are right now. So this here, as you can see highlighted, is going to access this. It's going to set the data we were just given to the data we were just given. Great, that's fucking beautiful. That is perfect functionality. That's exactly what no, it isn't. Of course it's not. There are 2 things we can do. We can go, oh, well, I'll just, set the author here. And that will then call set author's function, and it will just pass in this data. And it knows how to do it because it's just author equals data. That's fine. And honestly, the whole point of getters and setters is to, set the data and run it through the validation. And the whole point of that is we can change the validation later. We can make sure it's not empty. We can make sure it doesn't have any non-Roman, Arabic, whatever our fucking alphabet characters are, non-English letters or whatever. We can set validation for languages. We can go, oh, this guy, what nationality is he? Oh, his name is Ormondo. So he's whatever the fuck nationality Ormondo is. It's Jason, so we'll assume he's English. It's Lucia, so it's Italian. Whatever. But if we don't call that function now, we'll have to change it later, which is shit. But let's go on the assumption that we want to do it like this. Author is equal to author. So how do we make this work? There is magic in C++. Just so much magic. But this is one of my favorite types of magic. We have a pointer, which is just a piece of data called this. And what this is, it is the current object you are sitting in. So much like going here and going mybook.getAuthor or mybook.setAuthor, we can just go this dot, and it turns it into a little arrow majiggy. Is it gonna, yeah, there we go. Now the arrow majiggy, just pretend it's a dot. It's pretty much the same thing. It's a little bit more advanced, and I really shouldn't be showing you this, but I didn't mean it, so we're just gonna go with it. It's just saying access this object that we're currently in and author. We have not changed the scope of author, but we're accessing it from somewhere else. Technically changing the scope of author. So this will set this object's author to author. Now, generally speaking, you want to try to avoid this. So the way I avoid this is like adding a letter to the front of all these. So it'll be like Q author. So we can just go author is equal to Q author. And this one here will be M author, M for member. But once again, that is up to you. That kind of putting stuff before the variable came from when you didn't have a lot of screen real estate. You had 80 by 40 columns, and that's all you had, one screen. And you didn't have a mouse, and you didn't have real advanced functions like finding or that peek like I had. So you had to have ways to determine very quickly what was what. If it was Q, it came in from a function. If it was M, if it's a member variable. K, it's a constant. Whatever, L, it's a local. You created it in the function. But it's not necessary as much anymore. Because, I click this, and it points to where it's coming from. I can go to declaration, and it'll just highlight where it came from. I can put the header of this file on another screen, and I can see it over there. It's not as important, but I still do it because force a habit. That's the way my last work did it, so I just sort of ingrained it. I do want to get away from it. And I think this is a good example to show you why people still could do it. That's showing you 2 ways of doing it. This way is a little bit, I can understand it. If this is never going to have validation, like you could set it to blank, you could set it to Italian, set it to Japanese, whatever, it's just going to work, that's fine. whereas number of pages here we need to validate. And you don't want to copy and paste code. That just defeats the purpose of having a function. So what we'll do is we will change this to Q title to, yeah, so this one is also called title. Consistency is key, as you can see. And we'll set our publishing house is, I promise you I'm a professional and I know how to type. And I'm not actually just fucking terrible at my job. So set publish year to year. Now, if you actually name things properly, you will actually get IntelliSense, and I don't think I actually have it installed. Let me just have a quick look. There's an extension called IntelliCode. I have got it installed. That can actually, it uses neural networks and machine learning to pick up on your coding style, and it'll actually suggest things pretty accurately for what you actually want to do. And it's really fucking incredible when it starts working. You have to actually train it though. And it works better if you're working on one project and you're building one project rather than what I'm doing here, which is 8 different projects. But that's an aside. Don't worry about that. You should get it anyway. So now, once again, we haven't changed this. We've added just using a constructor, and we've just going to output the second book. And it should be author was 21, this many pages. I should probably add a second end line so we can actually determine where they split. I'm just doing my heading. Titled by author, titled by author, published in 1990 by House. Words, the author was 21 and there are this many pages too. That's our second book and that's our first book there. We have just used classes. This is one of the most powerful things that C++ brings to the table. And this is only the half of it. You can do so much more with classes that I will be going through in a future lesson. And that is when object-oriented programming, in my opinion, just blows literally every other type of programming out the water, which is, I can't remember the name of it. Linear programming? Look, I don't remember. I only used it in like uni. You know, use C before you use C++. To sort of get into that mindset, because C++ is object-oriented programming and C isn't. So it's simpler, but it's really not. So yeah, classes. I did want to talk about structs, but I'll go a little bit into that now. But yeah, so classes. And we've learned about access modifiers, which are public and private. There is a third one in C++, and some other languages like Java will have another one. The one in C++, which we're going to go into later, is called protected. Just to sort of give you an example, you might actually see it if you are the kind of person who's like, okay, I'm learning to code, I want to go and look at other code and sort of get an idea. You might see that word protected. It's just another access modifier. In Java proper, there's package, I believe, is another one. And I think a couple of other languages have certain other kinds of access modifiers. I know C# has sealed, which doesn't really count, but it is. It's kind of hard to explain. Yeah. So I'll quickly go into structs. So if I change a class and a struct on the surface are pretty much the same thing. And I can prove that. If I change class to struct and run it, it does the exact same thing. Why do I have both then? Okay, there are 2 reasons. Firstly, the main difference between, the main user-facing difference between a class and a struct is by default, a struct is public, whereas a class is private. So I can remove this public here. Not that you would, and that will still work because by default, it's public. Whereas if I change that back to class and then remove this, it's going to go, I can't access a bunch of stuff, which is all the stuff that's in the public, that we want public. The second example is, the second difference is how it sits in memory and how it presents itself to the machine underneath. You can do funky stuff with structs that you can't do with classes, like you can read a chunk of memory into a file and then read it back on top of where the struct sits, and it will just go back in. Much like if you go to your bookshelf, grab 6 books, take it off, and then put it back. It's gonna do exactly what you think. Whereas with a class does padding, and it does other weird stuff with how it actually has the stuff sit, and it might not always be in the same place. It should, but it might not. So you can't do that kind of thing. It's very useful if you are doing network programming to use structs, because you can just get a big chunk of data from the network card, shove it into a struct, and then everything just goes in the right place, providing you've programmed it correctly. Instead of going through the constructor and going, here's my data, or whatever else like that. That said, the main thing I personally use structs for is I will use structs when it is, struct is short for structure. I will use structs, and I think this is actually a common thing amongst programmers, but don't hold me to it, when all I'm storing in a class is data. So if I wanted to store book without all this extra functionality, I would probably just use a struct and just have this in there. So just literally be struct book with 2 O's, not 3, and it would just be this. Because it's public, I don't need the access modifier, there's no functions, but in the end, they are pretty much the same thing. We just use classes more, because I think they do some other funky stuff that I don't really remember. I have not used C++ at that kind of low level in quite a while now. My new job doesn't use C++, so it's just I'm sort of jonesing for it. But if you see struct, you can internally replace the word with class, and it should still make sense. It'll still work. And as you can see, I've put 2 classes in this book file. That's fine. If I want to move this struct book into up here, that is also fine, and I can access it here. Where it sits doesn't really matter. Generally speaking though, and this is not a hard and fast rule, because I don't do it all the time either, because there are good examples where you wouldn't. Generally speaking, 1 class per file, the name of the file is the name of the class. I believe there are some languages that actually enforce that. I think Java enforces that. You have to have the name of the file the same as the name of the class. At least it was. Don't quote me if it is anymore, if I'm misremembering the language. But that is just where you go, okay, I'm looking at the files. I have book.h, that's my book class. I know that's what it is. That's fine. If you have a file called classes and you have 100 classes in there, that's going to be shit to read. But if you have a file called data structures and you have your book and your shelf, which is just a list of books, it makes sense. Or if you have something like, I need my book to have another class, which is just going to be called, pages, just say, or a struct called pages. And it's just going to have, a page. It's just going to be words. And I can go up here and go, I got an array of pages. Or an array of page, sorry. Have I done that wrong again? I don't remember how to do this. Fucking hell. Yeah. Nah. Whatever. Then I can do that. And that makes a lot of sense because, my shelf class or my item class isn't going to use page. It's just going to be used by book. Then it makes sense to put it there. And once again, I do that a lot. If I want to create a class for reading something in from a database, and that class, the file I'm writing it for is just it's only going to be used by that class, I'll just put it in the same file. It saves me creating a file, it's all in one place, saves the end user or whoever's using my code going to find it, yada, yada, yada. Once again, it's all relative, it's all dependent, it all matters how you want it. Just once again, this is how I do it. The syntax I talk about is, pretty absolute for the most part. The coding style is definitely whatever you want if you're working on your own, or whatever the group has decided if you're working in a group, or whatever the company decides if you work at a company. Don't be that guy that goes to a company and say, I don't like your style, I'm going to use my own. You will be fired, and I will laugh at you. There is no exceptions there. You don't like it, go work somewhere else. It's as simple as that. Or put in a request for a change to get everyone to agree. You don't go cowboy. That is the worst thing you can do. And I had people who would do that, and it'd be like, code reviews, fix your fucking formatting, you fuck. And then they do, and they get all pissy about it. They'd be like, too fucking bad, I don't care. Or my favorite was when the boss didn't like my style. I'm like, well, I'm going by the style guide, and what did he do? Went and changed the style guide. What a cunt. You know who you are. Not that you're going to be watching my stuff because you don't know how to code. And he's sales now. I think I've rambled enough. Good fucking God. This is classes, basic overview, collection of data and functions, reusable, so they're great. You can add functionality, so people who are already using your classes then gets free functionality, and that's fantastic. You have data encapsulation, which is I'm going to keep it up again, you hiding your stuff away, which is fantastic again for stuff like pages and years. So you can, validate. One example I didn't really say is instead of setting the author's age here, I can go set author's birth year. And I can go author's age is equal to 2018 minus data. Like, that's one thing I can do. Or more importantly, I'd probably just do this, to be honest, to set author's age. Oops. To, 2018 minus data. Obviously, you wouldn't hard code 2018. You'd get the date from the clock and, whatever else, etc., etc. And then I can sort of go, set author's birth year to, 21 years from 1997. Whew. It's been a while since I was 21. And, it's 21 again. That's what you'd expect. So those are the kind of things you can do. You can have functions calling functions. You can have, get given stuff, take stuff, output stuff, and it's all self-contained. That's the important thing. And once again, you can really see the neatness difference as well. That's one of the more important things as well. It's very neat. Like, you have 6 things here to create one book, and you got to do 6 lines here to create all the data, whereas here, all done in one line. That's awesome. It's so much neater. 12 lines down to 1. And then you have the functionality of them pulling that data out in one line, rather than this big fuck off disgusting thing, which you then have to go and change if you want to change it, and etc., etc. So that's the cool thing. And once again, with this set author's birth year, you'll notice that I don't actually have a birth year thing. The functions you create for classes don't always need to be representative of the data you have. They don't always need to take data. They don't always need to give data. Everything is just, relative to what you're actually doing. A lot of my game functions, you'll go, okay, take an int, and then what I'll do with that int will be, it's like a selection or a menu. Like option 1, you've given me option 1. Okay, well, I'll discard that. I've now read it. I can get rid of it. Go do whatever I need to do. You don't actually have to save the data. You don't have to represent data in your class. It's just a matter of getting what you need. And I think, I was talking with a friend of mine. I was helping him. I'm teaching him how to code. That's Reaper. I've spoken about him. I work on his channel. Go have a look at it. It's great. I promise. I'm there, so it's all obviously great. But the basic formula for functions is, and especially member functions, it's especially important for member functions, is what is the data you need? What is the data you have? Where those two things fall short, so you minus what you have, what you need from what you... No. You minus what you have from what you need. What is left is the parameters you need for that function. So for instance, to set an author's age, you need the age, the new age, and you have nothing. So that the data you need, the parameters you need is the new age. Or a get function, What do you need? You need the published here. What do you have? You have the published here. Those two things minus each other, you got 0 left over. Things like this output function. What do you need? You need the title, author, public, etc. And what do you have? You have all of them. What if you then want to change this to, give me an option. Do you want to output in option 1 or option 2 where I make sure everything's capital letters, everything's camel case. I, be really verbose with the way I do it. Maybe you don't want me to print out the words. So if I want to say like bool print out words. So what do I need now? I need the return title, the title, author, words, year, etc. What do I have? And the output format. But I have all the data, I just need the output format. That's what's left over from what I need versus what I have. I'm not going to change that because then I'll have to change the function that calls it. And this is the end of the lesson. I've been rambling for like 90 minutes now, minus the editing, so like an hour and 15, hopefully, a bit less. We'll see. I honestly hope I've done a good job of explaining classes to you. Classes is extremely important. It is one of the more important things I hope to teach you in this series, where up till now we've done all the basic stuff minus like arrays, which is a little bit advanced. Classes is where programming really opens up. Now, back when you couldn't do classes, obviously you worked around a lot of copy and pasting. But with classes and the extra stuff I haven't even taught you about classes, you can do some really fucking cool shit. And if you're smart, you can really bend programming to your will using classes and the extra shit it gives you. And I think that's it. I think I will stop here. I hope you've enjoyed this lesson. If you haven't watched the lessons before it, I would highly recommend watching them all in order, which I should put at the start of the video, but I mean, you guys know how to count. You don't watch episode 8 before episode 7, unless you're an anarchist or something. Next episode will either be operators or pointers, or one of the other things I haven't put in, like the difference between a header file and a CPP file. I definitely need a lesson on the extra stuff in classes, but I haven't sort of plugged that in yet. And a lot of extra stuff. I just did function overloading. I'll probably go into a little bit more function overloading with operators maybe. Yep, that will be next, I guess. I hope you've enjoyed it. Share it with your friends. Let me know if I've done okay or not. If there's something you think I've missed and I can explain it to you a bit better, let me know. Constructive criticism is very much always welcome. And once again, I really appreciate it if you have watched this, especially to the end. I know I ramble a bit, and I'm not sure I'm a great teacher, but I'm giving it a go. So thank you, and I will catch you on the next one.